In our next section, we're going to continue our discussion of the ASA and talk about how access control lists, or ACLs, work a little bit differently in ASA versus iOS. We're also going to talk about the object groupings and the objects in ASA and look at the differences between the older code and the newer code, some of the changes that happened with the access lists. And up to this point, we talked about the general filtering logic of how the ASA works as a stateful firewall, and that traffic by default is going to be allowed from higher security level interfaces to lower security, where typically our inside interface would be a security level of 100, outside would be 0. Then traffic is going to come back from the lower security to the higher security if the state already exists. So when we looked at this visually in our diagram, we had the test PC that was configured on the inside interface of the ASA, which again was security level 100. We had the link to router 2, which was the outside, which was security level 0. So this means that any traffic that is being inspected, for example, TCP port 80 for our web browsing traffic, when this exits the outside interface, the ASA is going to create that information in the state table. Then when the flow tries to return, it is first going to check that state table to see whether the return packet is going to be allowed. Now, we also talked about the inspection engine, that not everything is actually inspected by default. We see from the command line that there's the default inspection class that is going to be matching TCP and UDP flows, plus a couple application level inspections like DNS or phone calls like H323, SIP phone calls can be matched, but not all flows are going to be matched automatically. We'll see once we get into some more advanced inspections doing the layer 7 matches with the modular policy framework. There are more details that we can get into with the inspection policy. Now, this also means that if there is any type of non-standard protocol that the application inspection engine cannot deal with, the way that we're going to allow that to return is going to be with an access list. Now, we previously saw this in iOS when we were dealing with non-standard applications like traceroute, that if the firewall does not know that the outbound flow and its returning traffic flow are matched on a one-to-one basis, it's not going to allow that flow back in. So if we were to look at this like in our particular case, and let's say we go to router 1 here, which is on the DMZ interface. The DMZ interface is configured as security level 50. And if we go to router 1, let's see if we can ping to the outside. Let's ping 136.1.215.2, which is router 2's address. We can see the flow goes out and the return packets are coming in, because on the ASA we have it configured to inspect the ICMP flows. Again, if we look at the show run policy map, which is going to show our default inspection policy, so the global policy says that beyond the normal inspection default traffic, which is going to be like TCP, UDP, there's these particular application level inspections like H323 phone calls, SIP phone calls, and then we added ICMP towards the bottom. Okay, same would be true if we were to do, let's say, a telnet. So telnet uses TCP port 23. It's a standard TCP application. So if we look at the ASA and look at the show connections, we should see it knows that that port 23 return traffic should be allowed back in on the outside interface. Now again, for anything that is a non-standard application, for example, our traceroute, where the traceroute is going to be outbound UDP in order to solicit inbound ICMP replies, the ASA is going to have a problem with this. So very similar to the CBAC or the zone-based firewall in iOS, since it cannot connect to the outbound UDP echoes to the inbound ICMP unreachables, so either the port unreachable or the time exceeded, it doesn't know to allow this back in through the inspection engine. So this is going to be one of the main applications then of why we would need to use access list in the ASA, is that it's going to be for manual exceptions for anything that we maybe don't want to inspect or maybe we cannot inspect it. So essentially the inbound access list and the global access list in the newer versions is going to be bypassing the security level functionality. where again, normally we're allowed to go from high security to low and then return. We normally would not be able to go from the outside to inside, and thus we have an ACL in order to bypass this security level. Now, very similar to iOS, we can only have one ACL per direction per interface. So one outside in, one outside out, or we can also have a global ACL. So this global ACL, this is one of the big changes as of ASA version 8.3, and we'd see the functionality is different from the regular ASAs if we're running 8.2 versus the regular ASAs running 8.4 or the ASA X. Now, since we're introducing another level of complexity, we also now need to think about what is going to be changing in the order of operations for the ACL processing. Now, without the global ACL, it's pretty self-explanatory how this is going to work. If we simply have one access list, let's say outside in on the interface, we know that the ASA is first going to check the state table, then it's going to check the ACL, and if there's no match, then it's going to deny. Okay, again, this is when we're going from outside to inside, which is our security level 0 to our security level 100. But now, since we're introducing another ACL that is global to the ASA itself, it starts to complicate the order of operations a little bit. Okay, this is especially where the packet tracer that we looked at previously is going to be very useful in the ASA, because that shows us exactly the step-by-step order of operations that the ASA is going to process the packet in. So if for some reason you don't remember exactly what the order is, or you're confused about the individual result of the flow that's happening, use the packet tracer and then it'll tell you, is it an access list issue that you're running into? Is it an access list on the interface, inbound or outbound, or is it related to the global ACL? Now, specifically, the order for the incoming traffic is that we're going to check the incoming ACL on the interface, then we're going to check the global ACL, then we're going to check the outbound ACL. So if we were to say that the flow was going in this direction, where we're going outside in, it would say check the outside in ACL, then check the global one. Then if there is an inside out ACL, that would be the third check. Now, what gets a little bit strange about this is that when the global ACL is configured, the implicit deny from the inbound ACL is not going to be processed anymore. So normally when the traffic comes in, the ASA is saying, look at the state table, is it a connection that was already initiated? If so, it's going to allow it back in. Same as CBAC or same as Zone Firewall does. Then it's going to look at all the permits in the ACL and say, is this an exception that I'm supposed to allow? Then normally I'm going to fall back to implicit deny. However, in this case, if we want to continue onto the global ACL, we essentially have to ignore that implicit deny and then move on to whatever the global statements say. So in the case that we're configuring both of them at the same time, both the inbound ACL and the global ACL, we're essentially merging the rules together. So we can think of the global ACL as essentially appended onto the end of the inbound ACL. So we're going to process first the inbound ACL, then we're going to process the global ACL, then we're going to fall back to the implicit deny of the global ACL. Okay, so let's take a look at a basic example of this, where we saw that the trace route that was coming from router 1, we have the UDP echoes, or basically the random UDP high port traffic going to the ASA. ASA should then continue to forward it on to router 2, but as the flow returns, ASA is going to drop it because it can't connect the outbound UDP to the inbound ICMP error messages. Now, as we saw previously, we can see this on the ASA as long as we turn logging to the console on at level 7. And we'll say logging console 7 and logging is on. Then if we were to do a trace route from router 1, we should see the ASA says we're denying the inbound ICMP, which is type 3 code 3. That's going to be the unreachable message that's coming in from router 2. So on router 2, if we were to look at the debug IP ICMP, we see the port unreachable message is going back to router 1. So it's not an issue, again, with the traffic being filtered as it is leaving the ASA. It's an issue with the traffic returning. So by default, all the traffic is allowed to go from the DMZ to the outside here because we're going from 50 to 0. It's only an issue when we're going from 0 back to 50. So in previous versions, normally you would fix this problem by configuring the ACL and then applying the ACL inbound on the outside interface. However, it gets a little bit more complicated if we have multiple outside interfaces or we have multiple inside interfaces. You know, we have to maintain multiple different filtering policies. So by moving to the global ACL, it makes the maintenance of the filtering a little bit easier because we just have one global filter that essentially applies to all traffic. Now the application is essentially going to be the same, except that we're just applying it globally as opposed to applying it at the interface level. So here, let's say no logging on, and we'll configure an access list. Let's say that this is our global ACL, and for simplicity, let's just say the global ACL says permit ICMP any. Then the access group is applied, global ACL is applied globally. So it's for traffic on all interfaces. So on router 1, if we try to do the trace route again, and let's turn logging on the ASA again. So globally, let's say logging on. Okay, now it says we're denying UDP from the DMZ interface going to the outside because of this global ACL. So what is changing now in the behavior then when we applied the global ACL here versus having no filter? So let's look at the config here. No logging on. And we'll show run include access list or access group. So we have the global ACL. It says permit ICMP traffic and then apply this globally. Now, as I mentioned, where this is specifically going to be applied is that first we look at the inbound ACL, then we look at the global ACL, and if the global ACL is defined, we're going to fall back to its implicit deny. So it's changing the behavior of the filtering logic here, that if you do define the global ACL, you have to essentially have an explicit permit for all traffic that you want globally, or you would have to make another exception on the essentially the higher security level interfaces inbound. So in some manners it does simplify the filter, but in other manners it actually makes it a little bit more complicated, because we have this extra step in the order of operations, where previously we were essentially allowing all flows to come in on the DMZ and then go out, or come in on the inside and go out. But now when these come in, they're saying first check the in ACL. Okay, there is no in ACL configured, so we continue on to the global ACL. Global ACL. And the global ACL here has an implicit deny at the end. So typically when you do this, if you do want to allow all flows from the higher security level interfaces inbound, you would also need to configure another access list that applies on that link that essentially says permit all traffic in. Okay, the other option would be to do the permits based on the specific sources of the traffic. So I could say permit all traffic that comes from 136.1.115 or from 10.1.0. Then regardless of where it's coming from, if it's coming from this link or this link, the global ACL is going to match. But it's kind of a strange behavior if you didn't know it works this way, that it does enforce the implicit deny essentially on all interfaces. So again, there's two ways that I could fix this. I could say for access list global ACL to permit IP, and then let's say that source segment. So the source is 136.1.115.0/24 going to anywhere. We can see now the trace route is allowed to go from router 1 out. So essentially this first line now, if we show run access list, this first line is saying allow the return ICMP from router 2, so that would be like the trace route replies. The second one is saying allow the traffic from the inside segments. Okay, the other option would be like if we went to the test PC. The test PC right now should not be able to ping. Actually, it will be able to ping because I said permit ICMP, but let's ping 136.1.125.2. Not 125, 215. 215.2. Okay, we can see that the ping goes through because that's coming in here. There's no in ACL, so we go to the global ACL. Global ACL is saying permit ICMP, so the traffic is allowed to go out, and then the return flow comes back in. If we were to try to do a telnet, what would be the result of this now? It's going to fall back to the implicit deny of the global ACL. So again, there's two ways to fix this. Either on the global ACL, I could add the explicit permit for traffic coming from that source segment, or I could add a new ACL that I could apply in on the inside interface. So we could do this. We could say access list inside in permit IP any access group inside in interface inside. Now from our test PC, now we're able to telnet. So again, it definitely is a useful feature of the new versions that we can use the global ACL, which essentially applies to all interfaces at the same time. But you have to remember this last point, that it is going to fall back to the implicit deny unless we have either an inbound ACL that is being processed first doing the permits, or we configure explicit rules in the global ACL in order to allow the traffic flows. Now the access list itself is very similar to iOS, so we can match on things like the source address, destination, the IP protocol number, like is it OSPF, is it EIGRP, is it ESP? We can match on the layer 4 information like the TCP UDP ports, ICMP type codes, time ranges. So most of this is self-explanatory. It works very, very similar to how iOS does. And then likewise, it always ends in the implicit deny. Now, one of the differences here, where in iOS we have the difference between the standard ACLs that are matching just on source and extended ACLs that are matching on anything in the layer 3 or layer 4 header, ASA doesn't do this. ASA just says it is an access list, and there's no difference in the naming convention between the two of them. So we can configure the ACL to match just on source if we want to, but the disadvantage of this is that you cannot mix both of them in the same list. So as a general rule, most of the time you would want to use the extended ACL syntax, where you specify the source and the destination, because otherwise you're only going to be able to do filtering based on sources, not based on any of the layer 3, layer 4 header information. Okay, the other very key point, and I mentioned this as we were talking about the routing protocols, is that the ASA uses subnet masks as opposed to wildcard masks. So if we wanted to say to permit a specific host, let's say access list 1 permit IP host 1234 going anywhere, and if we show access list, this is the equivalent of saying not permit IP 1234.0.0.0.0. It's actually the subnet mask of all 255s. So we can see this line here, it errors out. It says that 1234 and 0000, that doesn't match up bitwise. That doesn't make any sense. Masking all ones against this does make sense because that's the equivalent of saying that particular host. And when we can see this when we show run access list, ACL1 and ACL2 are essentially identical here, but from a syntax point of view, the first one I said permit the host 1234. The second one I said permit the source 1234 and mask it against all 255s. Because again, it's using a subnet mask here, it's not using a wildcard mask. So do be very careful of that. As a general rule, once you configure your ACLs, just look at this output in the show run access list and make sure that if you're trying to match individual hosts, that it appears there, or if you're trying to match anything which would be all zeros, that the any keyword appears. And again, the same was true with the routing protocol. So when we're using OSPF or EIGRP, in iOS you use a wildcard mask to match what are the interfaces running the protocol, but in the case of ASA, we're using a subnet mask. So if I wanted to say just the address 1234 is running OSPF, we would mask it against all 255s, not against all zeros. Now additionally, just like iOS, ASA does support object groups. The iOS object group actually came from the ASA implementation, where this is basically just for simplifying the management of the access list. So we could group similar hosts or similar networks or similar services together, where I could say I have an object grouping that is going to be all the IP addresses of my public web servers. So it makes the changes and just the maintenance of the ACL a little bit more modular and easier to deal with. Because if we change the object group, it's going to change all the access list entries that are referenced by that particular group. Now in the object group, there's 4 different types of grouping, where we have the protocol, which would be like, is it ESP, is it OSPF, is it a GRE tunnel? The network would be what is the individual IP host address, what's the subnet. The service would be what's the layer 4 port number. So is it DNS, is it Telnet, is it SSH? And then the ICMP type. So is it a ping, is it an unreachable, etc. Now this is important to mention here because these object group typings cannot be mixed together. You cannot have an object group that is matching the port number and the host address at the same time. We would have to have one object grouping that says these are the host addresses, a separate grouping that is saying these are the port numbers, then we combine them together and it's going to expand fully into the individual access list entries. So for example, if we were to have a long ACL that we're trying to allow specific services to our internal web servers. So let's say we want to allow clear text web browsing at port 80. We want SSL, which is port 443, and we want send mail at port 25. And it's specifically from this host, 200.0.0.1, going to 10.0.0.100, going to 10.0.0.101, and then from an additional host. So basically, we can look at what are the commonalities between these and then group them together with the object groups. So instead of specifying these outside hosts individually 6 times, we could say instead, let's just define these as the outside addresses in a grouping. So this would be a network grouping. It's going to be these 2 particular hosts. Then we have the destination. So this is our inside servers. And then what are the particular services that we're trying to reach? So web, SSL, and send mail here. Then from the access list point of view, when we reference the object group, we can see we're saying it's TCP object group. The outside trusted host is going to be the source. The object group public inside servers, that's the destination, and then the object group public inside server ports is the layer 4 port information. Now you'll see that when you actually configure this though, if we were to say something similar like object group, and again the 4 different types, the user one, we'll talk about this later. The object group, let's say that this is for the network. These are our servers, and the servers are host 1, 2, 3, 4, and, or not host name, it should be the network object. Network object is the host 1, 2, 3, 4, and 5, 6, 7, 8. Okay, so those are our two servers. And we have another object group. Let's say that this is the service, and the service is going to be our web ports. Okay, our web ports are the service object. Service object TCP 80, TCP destination equal to 80, equal to 8080, and 443. So maybe our servers are listening on 3 different ports. If we show run object group, okay, we can see our 2 groupings, and now we're going to combine them together in an access list. So we'll say access list 3, permit TCP any source going to the object group, the servers, and at the ports that are the object group, the web ports. That should say, so let's say we're coming from anywhere, going to object group servers. I may need to say and the context-sensitive help here is not very intuitive with this. Let's see, what was the full syntax I had? So access list 3. Permit TCP from any source going to the object group, the servers, equal to the object group, web ports. So service for the destination port, object group, web ports. Says the specified object group web ports has the wrong type, expecting the service type. And what did I define this as? Let's say show run object group. It is defined as an object, or it is defined as a service. Let's try this. Let me remove the other entries. And let's try that again. Service object, TCP destination. Actually, this should say not the service object. This should say the and what did I say before? Service object TCP destination equal to www. So the syntax here, this version I'm using today is 8.4. Yesterday, or the previous sessions, we were using 8.2. because we're going to look at some of the changes here, and there are some syntax differences that I'm going to talk about next, because they introduce a new object that is a little bit different from the grouping. I may actually just be referencing this in the wrong order. And let me reapply it the way that I had it before, which is permit TCP. And it is saying to specify the service object group first. So it should be a different order. It should be permit TCP object group the web ports that is any source going to the destination of the servers specified object group web ports as the wrong type, expecting the network type. Let me check let's check the syntax example for this particular version, because this changes between 8.2 and 8.4 and 6. Okay, so from the main documentation page, again, we go to products, security, firewalls, ASA 5500, configuration guides, .8.4. Then this is going to be under I'm not sure if this is under objects and access lists, or if it is under Okay, this one is saying the following access list uses object groups to restrict several hosts on the inside network from accessing several web servers. Access list ACL in extended denied TCP object group denied object group web equal to www. So where do we specify? Well, let's look at it like this. Okay, if we were to say permit TCP any object group, and what was the name that I said? So let's say show run object group. TCP any object group the servers. Okay, if we show run access list, ACL3 is specifying just what is the grouping. If we look at the show access list, this is going to show the full expansion, where for ACL3, it's expanding the object group servers into the individual destinations. So host 1, 2, 3, 4, 5, 6, 7, 8. We shouldn't need to use the extended keyword because it's essentially implied anytime that we're using the source and the destination at the same time. Let's say show run object group. It's this particular syntax here that changed. Previously, this says that it was the port object. Service object, let's say TCP UDP. You know, I'll have to check this on break because I know this syntax does work in 8.2. Something in the order is wrong here that I'm specifying. So let me take a look at that. I don't want to spend too much time on that because the real key that I wanted to talk about here was the change in this particular version to move away from object groups and to move to what is defined as the objects. Now, the difference between the object group and the objects is that the object is now introduced with the NAT changes that happened in 8.3. Okay, so it's not the same thing as an object group. This is going to be required anytime that we define the new NAT syntax with object NAT, which is going to be a little bit different than the equivalent of the policy NAT in 8.3 and later, which we're going to spend a very large amount of time on this because it's not very self-explanatory how these changes worked from the previous global and NAT syntax to the new object and the new version of the policy NAT, which is now called the twice NAT. So we'll come back to this later. But the object, one of the differences here is that it can only contain a single entry, which would be like a host or a subnet. It could also be a service, which is like what's the protocol, what's the TCP source destination. Okay, we'll talk about when we would use these particular ports when we're doing the twice NAT, which is going to be the new version of the object NAT, or excuse me, it's going to be the new version of the policy NAT. Now, when we look at the difference between the two of these, so why would you want to have both of these definitions? Why do we need the object group versus the object? The difference is that in this new code, the objects are going to be referenced both from the ACLs and NAT at the same time. So this means that if you are defining your inside servers with an object, and then this object is called from the NAT syntax, and we also have the object that is mapping the public address. So let's say, for example, that we have a server that is 10.0.0.1 on the outside, and on the inside, that's the private address. And on the outside, it's some public address, 1, 2, 3, 4. So we would create an object that is matching 1, 2, 3, 4 to apply that to the NAT syntax that says translate 1, 2, 3, 4 to 10.0.0.1, like a one-to-one translation. But at the same time, we would still need an exception in the ACL to say when traffic comes inbound and is going to 1, 2, 3, 4, we want to allow that in because we're going from outside to inside. Okay, the major change we'll see here is that when the object NAT was introduced, they changed the order of operations and also which address do you need to match in the ACL. Do you match the public address or do you match the private address? With the new syntax, you need to match the public address, which means that the object that you're using for NAT should be the same object that you are using for the ACL. So at the end of the day, the change is not very self-explanatory, but when you look at the result of it, it's actually cleaner to do the config with the object and the object called from both the ACL and NAT, because anytime that we want to make a change, like for example, if the web server moves to a new address, we change the object that is matching the web server, and it updates both the NAT config and the ACL config at the same time. So the object group is only being referenced from the ACL. It doesn't have anything to do with the NAT translation. But the object is going to be for both of them at the same time, both for the ACL and for the NAT. So for example, here we have an object that's saying this is the particular source. This source is the host 10.10.10.10, and the destination is anything on this subnet, 100, 100, 100, 0/24. Okay, the service is IP, so we're saying just IP at layer 3. We're not matching any of the upper layer protocols. And then we can match this from the access list. So as opposed to saying the object grouping, we're saying the object. But again, the difference here is that the object is only matching one entry. It's not matching multiple entries at the same time. So the grouping can say, you know, these are the destination ports, these are the destination servers. The object is always going to be on a one-to-one basis. So one source, one destination, one source subnet, one destination subnet, and then the same for the protocols and the ports. Okay, there's a question here. Can we specify this? Access list for permit TCP any object group, the server ports. No, it's not called server ports. What was it called? It was called web ports. And it's saying object group web ports is the wrong type, expecting service type. You know, let me try this. Let me try not using a number. Access list A. Error specified object group web ports has wrong type, expecting service type. Let me see real quick what are the other types. If we say object group, we said the service, these are the ports, and the service object and you can see you can actually nest these together. You can call the object from inside of the object grouping. So then this would match the actual host. Then if you change IP addresses, you update just the object, and it's going to update anything else that is referencing it. But let's say service object is TCP destination 23, destination equal to 23, and show run object group. Access list, EFG, permit TCP any object group, the ports. This was the previous syntax. Something changed in 8.4. I'll have to double check exactly how this needs to be referenced, because in 8.2 this was a port object, not a service object. They're saying access list ID, the line number extended, permit or deny the protocol or the object group, service object group. Maybe that's what it is, that we shouldn't say object group. What did I say this one was? Ports. There it is. So the order changed in this particular version, where it now should be then access list XYZ, permit the object group, the web ports, from the object or from any to the object group, the servers. So if we show run access list, in the older version, this was opposite, where this was the destination. Now if we show run access list XYZ, or not show run access list, show access list, it's saying TCP any host 1234 equal to www, which is what we're looking for. Now you'll see that if you do a code change from 8.2 to 8.3 or 8.2 to 8.4, it will try to do this conversion for you, but most of the time it doesn't really work out. So if you were to do this in production, you would really need to take your old config and you essentially have to go through the ACLs line by line and then make the changes. The same is true with the NAT config. Now you'll see this when you're using our particular racks on ASA 1 and 2. These are the 5510s, which are the non-X's. If you look at the boot flash, they have both the 8.2 code and the 8.4 code in there. If you want to change between them, you just need to change which one that you're booting. So if you say boot to boot system to disk 0, and then this particular version, this is the one that we're booting now. But if you wanted to use the older code, which has the old NAT syntax, then you would boot to 8.2. But you could see, you know, even though this is a minor change, if you were to take the old ACL syntax and then paste it in here, it's not going to work because they changed the order of how the object groups and now the objects work in the syntax. But the main point of this, the end result, when we look at the show access list, is that it automatically does the expansion for you. But in these new versions, you actually want to stay away from the object groups and try to replace them with the objects, because the object can be referenced from the NAT config and the ACL, where the object group can only be referenced from the ACL. Now, within the scope of the lab exam, they are generally not going to explicitly tell you what do you need to do with access lists in order to get the application functional. So for example, if your Radius server is on the inside of the ASA and the AAA client is on the outside, they're not going to specifically tell you, oh, by the way, make sure you open up TCP 49 for TACACS, or make sure you open up the UDP Radius ports in order to get there. You are going to need to figure this out by visualizing what are the flows that need to be allowed through the filtering device. So are there issues that AAA need to go through? Network time, our routing protocols, tunnels like GRE, ESP, ISACAMP, etc. The easiest way to figure this out, if you forget it, is to use the logging with the access list. So you can end the access list with an explicit deny and the log. That's going to show you the hit counter. But again, remember, you don't necessarily need to do the logging in order to see what the ASA is dropping. Okay, as long as you turn logging to the console on, if we say logging is on and logging console level 7, then it's going to tell you right there what type of traffic is dropped. But again, you will need to figure this out based on visualizing what's going on in the overall diagram. So if this, let's say this machine here is the EasyVPN client, and router 2 is the EasyVPN server. So we have the tunnel going this way. We have the UDP ISACAMP for our phase 1 negotiation. When this traffic returns on the ASA, is it going to allow it, yes or no? Well, it really depends. Is it inspecting UDP by default? It should be. Okay, so the phase 1 negotiation should be fine for the EasyVPN client. But now we actually form the tunnel. Okay, the tunnel itself is going to be ESP out and then ESP return traffic. So if the ASA is not inspecting this, we would need to manually allow this flow back inbound. And they're not explicitly going to tell you in the requirements, oh, by the way, make sure that you update your ACL and ASA 3 in order to allow the ESP traffic back in. So it's an implicit requirement of the exam, and you need to basically visualize what are the flows that will need to be allowed, and then update the filtering policy accordingly in order to allow for this.